Hi, everyone. We've just heard from Brittany about the cutting-edge applications of imagery helping to transform our disaster management response. I'm going to continue the conversation today by talking about how we apply aerial imagery and remote sensing in ArcGIS. ArcGIS today is a comprehensive imagery system. It supports all aspects of the imagery lifecycle, from capture through to visualization. In a bit more detail, ArcGIS allows us to create GIS-ready products with the Reality Suite. We can then manage, organize, and share imagery. We have tools, hundreds of tools, to analyze and exploit imagery both on the desktop and on the web. You can then visualize the imagery with your existing data on mobile, desktop, web platforms in 2D, 3D, and in time. Finally, Esri has lots of imagery content. So in addition to your data, the ArcGIS Living Atlas that Brittany just spoke about provides imagery-based maps and catalogs of past and present imagery, such as the Landsat series. A number of content providers also supply imagery in ArcGIS ready-to-use formats, such as web services or downloads. Today, we're focusing on the reality mapping toolset. Reality mapping is the use of imagery taken from drone, aerial, or satellite to create foundational GIS content that can be used within your GIS environment. So what is reality mapping? Reality mapping is described as creating an accurate digital representation of our physical world using images, LiDAR, or both. In our case, this can include satellite, drone, and aerial imagery. Let's look at the journey of the reality mapping process. Where do we all get started? When working with reality mapping, we always start with source imagery. This can be RGB, thermal, multispectral, and in the future, LiDAR, or any combination of the above. ArcGIS Reality creates products that can go straight into your GIS platform. Ortho aerial photography, we're all familiar with that one. Digital elevation models, DTM and DSM. Point clouds, it's the point cloud that provides the source for all these other products. And eventually, a 3D model, either in SLPK or 3D tiles. You can say that the 3D reality mesh is the foundational product for digital twins. All of these products come together to give us intelligence and context in our GIS environments. These core outputs provide the foundation to apply raster analytics and other imagery workflows. Let's have a look at them in more detail. The groups of GIS datasets that are created are, initially, full aero triangulation. You can supply source imagery and camera orientation information. ArcGIS Reality tools will then align the images and perform the imagery adjustments. This allows for sensor, pitch, and yaw, and removes distortion, the initial correction process. Then it generates a point cloud. Every location in the image is covered by many images. The sun angle, sensor angle, and time, if all is known. By combining all the information, it's possible to know the elevation for every pixel in every image. From this point cloud, we then create a DSM. And once we have the DSM, we can combine this into a full ortho photo, or a true ortho. And eventually, we can build the reality mesh. Why is this important? A few of us have talked today about GeoAI or deep learning. A true ortho is critical to extract building footprints to ensure accuracy. If you look at the traditional ortho here, you can see an obvious lean in buildings, trees, and other tall structures. It's as if the camera or our viewpoint is in a fixed location somewhere in the image. In a true ortho, every pixel is displayed in its geometrically correct position, which means that no matter where you look at the image, it appears as if we are looking directly above that point. And as we can see on the right-hand side, this makes true ortho ideal for extracting features from the image. ArcGIS Reality encompasses a full suite of photogrammetric software products. Drone2Map is our desktop drone processing software, and SiteScan for ArcGIS is also for drones, but this is a cloud-based platform. Reality Extension for ArcGIS Pro is designed for small aerial projects, satellite projects, and larger drone projects. Reality Studio is for multi-headed cameras such as Leica's City Mapper or IGI Urban Mapper. It allows for multi-machine processing and large server farm processing. You can also consume your own AT models directly into the Reality Engine for full AT generation. Reality Studio and ArcGIS Reality Extension for ArcGIS Pro come together as a package called Reality Desktop. Every product is underpinned by the same technology, the Reality Engine. With the Reality Engine, regardless of the form of software you choose, the outputs remain the same: AT, ortho imagery, DSM, DTM, and 3D meshes. How the data is created is the differentiating factor. Reality Engine ensures we have the scalability. Let's look at which product fits with which scale. For drones, we use Drone2Map, SiteScan for ArcGIS, or ArcGIS Reality Extension. For Nadir aerial imagery, we used ArcGIS Reality Extension. For really large Nadir projects, ArcGIS Reality Extension will be able to be handed off to the processing in ArcGIS Server in the near future. For multi-headed aerial cameras and large imagery projects, we use Reality Studio. It can be clustered to enable parallel processing, and in the future, we'll be able to run this through image-dedicated processing and analysis servers to reduce processing time. You'll hear more about this with our talk with APA later today. For satellite, you can also use ArcGIS Reality Extension. Let's have a look at how ArcGIS Reality handles scale directly. On the top, you can see satellite 3D mesh, kindly provided to us by Airbus. On the bottom is another 3D mesh provided by Aerometrics, and it's an aerial imagery produced product. Thank you both for supplying these images. Satellite is high frequency. Some providers have hourly updates and lower res. It's very useful for situational awareness and first pass analysis. Aerial is higher resolution, much larger areas. It has hundreds of thousands of images to produce a single metro mesh. This is much more costly to produce and needs specialized airplanes and cameras. So today, we're not comparing satellite against aerial imagery. We're just showing you the benefits of each and ensuring that the scale can be handled through ArcGIS Reality Engine. So regardless of your input data, it's fully scalable to support any input data. Another interesting side note, both of these scenes are served through ArcGIS Image dedicated infrastructure. Let's see how you can access this all through ArcGIS Reality licensing. So to start with, there is no impact with the recent upgrades in 11.4. Drone2Map is a standard 2D processing, and it also has advanced 3D processing. It is licensed for a named user on an annual subscription. It's ideal for desktop, particularly multispectral, thermal, or RGB inputs. It is also great for offline usage when you're out and about in the bush and need a quick proof of concept. SiteScan for ArcGIS is also based on a named user, but this has unlimited storage and processing as it's cloud-based. It also is great at volumetric customer subscriptions with unlimited users and processing. Reality Studio and Reality Engine come together, as I said, in Reality Desktop. The ArcGIS Reality Extension for ArcGIS Pro is again an annual subscription with monthly expansions. It's licensed per machine, and this is perfect for drone, small aerial projects, and satellites. Reality Studio is exclusively for aerial imagery. Let's have a look at ArcGIS Reality's ability to scale with different imagery types and sources from different products. Again, I'm going to show you something really exciting, and I'd like to thank Black Sky and Arc Infrastructure for providing these images. Here we have two reality meshes, both produced with Reality products. We're currently flying through Kalgoorlie in WA, We're exploring the big pit. The first set of imagery is from Black Sky and was processed with ArcGIS Reality Engine for ArcGIS Pro. It's 1.3 meter resolution across 7 by 5 kilometers. Many of our clients use this for rapid and frequent site assessments and for monitoring assets and operational activities. We're now flying across to a railway siding captured by Arc Infrastructure with drones, specifically the DJI M300 P1 camera, which is 42 megapixel. As it was flown at 30 meters, the ground resolution is sub-centimeter. You can literally see every single track, rock, and nail. They needed this to detail the exact asset IDs on each sleeper and inspect the conditions of every asset. So how did we do this? Pretty cool visualization tools. All of this was produced using ArcGIS Pro Animation Manager. All these fly-throughs are very simply created by setting up bookmarks, using the animation tool, and then exporting your fly-through. It's very simple and creates awesome content that really helps you visualize your data. If you'd like to hear any more about this, don't hesitate to come speak to me and my colleagues. So I'd like to thank you all today for your time. Again, you're welcome to come have a chat at the kiosks. You're welcome to also leave feedback via the survey. And for any of you watching back online, please click on the link below if you want to reach out. Thank you so much.